Thank you guys. It's so good to be here, to be back at the Commonwealth Club. I want to thank George Hammond for organizing this event, which is very unusual. You know, we're going to do not just a lecture, but also a party. And you will see why it is important, because the point I will make is that, you know, to revive Pythagorean tradition, we have to combine Apollo and Dionysus. We have to combine math and music. So if I only talked about it here, and then we all said, okay, nice, and go home, we'd still be coming up short. So we have to act, you know, the words, you know, the walk the talk. And so that's kind of how this idea came about. And so I'm very grateful to George for seeing this to fruition, and the Commonwealth Club for hosting it. All right. How do we revive Pythagorean tradition in the age of AI? Pythagoras is a kind of a mystic, almost mystical figure, a legendary figure. So what do we know about him? We don't actually even know precisely when he was born and when he died, more or less, around 2,500 years ago, give or take. But one thing we can tell is the origin of his name. There's a beautiful story, which we actually know from his biographers who came about 200 years later, that the name comes from there are two roots in the name. The first, Pyth, which comes from Pytho, the name of Delphi, where the famous Temple of Apollo is located. And at the Temple of Apollo, you had an oracle, who was a woman, that was delivering prophecies from god Apollo. And she was called Pythia. And my understanding is Pythia actually came from Pytho, which was the name of Delphi. So Pythia was an oracle who delivered prophecies. And so, why Pythia? I'll explain in a moment. And the second part of the name, Agoras, comes from Pythagorean, to speak publicly or to assembly. So Pythagoras could be loosely translated as the one who speaks on behalf of the oracle. Okay? So that's already pretty cool. And so the reason is explained by Porphyry in his, what appears to be the first biography of Pythagoras, around 270 BC, is that Pythagoras' father went to Delphi on business and brought offerings to Apollo, and then he went to the oracle to ask her questions. And so one could surmise that maybe he asked about his business, what he should do, and so on. But the oracle, basically, that's my rendition of the story. The oracle said, you're not asking me the right questions. Your wife is pregnant with a child, and she would soon bear a son who would surpass all men in beauty and wisdom, and who would be of great benefit to mankind. And she was right. See how interesting. Even before this man was born, he had a special connection to the divine, to god Apollo. And this will be, of course, a big theme of my talk. So that's, you know, just talking about his name, you already have a beautiful story, okay? So that's a good sign. But now, I want to talk about his contributions of Pythagoras and Pythagoreans. In fact, he himself did not leave any documents, written documents. Maybe he did, but they have not reached us. Some of his disciples, most notably Philolaus and Archytas, who came about 150 years later, they left some documents, some written documents, which historians have studied in great detail. There are books written about them, from which we kind of know what Pythagoras and his students talked about. But they definitely had a commune, they had a school of Pythagoras, which came to be known as Pythagoreans, the school of Pythagoreans. And so Charles Kahn, the historian, formulates it concisely very well, that the contributions of Pythagoras and Pythagoreans to Western culture, I would say not only Western thought, but Western culture, which is more encompassing, is twofold. The contributions are twofold. On the one hand, it was the idea of mathematical understanding of nature, which is where, you know, this is why I got interested in Pythagoras in the first place, because I'm a mathematician. But that was not the only thing. On the other side, it's also that idea of a human destiny which goes beyond the visible world, beyond the mere physical appearances, or as Joseph Campbell, in a quote which I will give later, talked about as apparitions of time, beyond the visible world and beyond the mortal body, but something that has to do with sort of a higher destiny, higher form of life. So this twofold contribution and this approach to life, which kind of a two-pronged approach, where you are considering both the kind of logical and rational side, which is what mathematics, at least ostensibly at first, on its face, is about. But in addition, a kind of a more mysterious, mystical, one could say, side of exploring it seriously and engaging with it seriously and not discarding it as something kind of voodoo or irrelevant, which unfortunately happened with philosophers who succeeded Pythagoras. More on that later. But now I want to talk about Nietzsche, the great German philosopher Friedrich Nietzsche, presented this. He was probably, in my opinion, as far as I know, the first Western philosopher who identified this issue of the pivot from Pythagorean ideas that I just talked about to what came later through the works of most notably Socrates, Plato, and Aristotle. There was a pivot. There was a change. So they set the tone, Socrates, Plato, and Aristotle. They have set the tone for the Western civilization, for the Western culture. And what they did, unfortunately, is sort of taken just half of the teachings, just the first half, just the logical, cerebral side, you see, and discarded the other side. So the way Nietzsche spoke about it in his book, The Birth of Tragedy, and that's 1872, he spoke very passionately. It's actually a beautiful book. I only read it in English, but even in English, it carries, the translation carries the passion. I imagine in German, probably even more. So he talks about these two sides of life. And he talks about them as being represented by the gods Apollo and Dionysus. So what's the Apollo side? The Apollo side is one that has to do with knowledge, reason, logic, rational thought. The cerebral side, the proverbial left brain, if you will. Or young, yin and yang, it's young. And Dionysus has to do with intuition, imagination, the mystery, rituals, drinking wine, engaging in revelry. That's Dionysus. So there is this polarity, seeming polarity in human life, which on the one side, of course, we want to be grounded in logic and reason, in mathematics, in knowledge. Without it, we wouldn't have this, that this event is at 5:30, and the address where we should appear, right? So if you just if you just drink wine and revel in a ritual, in a ceremony, you forget about time and space. So it's important. The Apollo side is very important. But Dionysus side is very important as well, because that's what brings joy to life. Of course, I'm not saying mathematics doesn't bring joy. It actually, my mathematical research does bring me joy, which most people, might find surprising, due to quite frankly, the atrocious state of our math education. But I'm trying to convey that beauty of the subject and the beauty of, and the reason why people like me, mathematical researchers, derive joy from it. So I'm not saying that mathematics doesn't bring joy, but joy also comes from being with friends, in discussing things that you love, being with your loved ones, and so on. So these are the two sides. Of course, in the final analysis, it's all one. I'm not saying, let's also not be too dogmatic about it. Let's also not say, oh, there is this side and there is this side. At the end of the day, it's all one. But to a human being with a body, there does appear this polarity, that there are two activities, so to speak, of that we do, things that we do in a human life, in the span of human life. And so harmonious life, according to Nietzsche, and I completely agree, means balance between the two. And so what Nietzsche did is he identified the point in time, which I think is correct, he sort of gave a correct diagnosis, when we went too much on the side of Apollo. And that happened after Pythagoras. So the view that I'm going to advance, the most important thing that I'm going to talk about today, if you will, I can summarize it by saying Pythagoreans sort of got it right. They were able to find balance. You see, and I will give you examples to how we know and the advantage of that. In other words, the benefits of that balance. But unfortunately, the philosophers who came after, they kind of discarded half of it. So here's what Nietzsche said specifically. He specifically identified Pythagoras and Heraclitus, and he also talked about the tragedies, the plays that were written by Greeks before Socrates, the pre-Socratic times, as we say, right? So that's what the time was kind of like. Of course, again, we shouldn't be too dogmatic about it. And it's a story that I'm telling you, but I think it's grounded in history, in the study of history, and the study of various documents from history, that indeed Pythagoras, Heraclitus, and others in the 6th century, more or less, BC, kind of had it right. And but then what sets in what he calls, Nietzsche, it's a quote from Nietzsche's book, The Birth of Tragedy, a profound delusion, which I think is a very proper word, which came into the world in the person of Socrates. So he blames Socrates, kind of like. Maybe it goes in too harsh on Socrates. Hasn't Socrates suffered enough? I mean, I don't know, but... So you add insult to the injury, the guy was killed. For his ideas already, and now he's being assassinated, by Nietzsche. But well, I think he kind of deserves it, because. So this idea that thinking actually is enough. That by thinking alone, by intellect, and when I say intellect, discursive intellect, just the thinking mind, that's just logical, rational mind. That's enough. That already reaches far enough to understand everything. Sound familiar? I mean, this is where we find ourselves in today's world. It's very hard to see somebody who say, I don't know. Especially if you go on Twitter. They all know, and they all tell you that you're wrong and you're stupid and so on. Not all of them, but some people who disagree with you. And that's become sort of a staple in our culture. And think of all the conflicts and all the strife that comes from it, largely manufactured, and also kind of following propaganda and a kind of a conscientious effort by our governments to indoctrinate people, to control. So of course it has very much, it made people much more susceptible to control. This idea that all comes from knowledge. Because then you do a sleight of hand and you replace sort of knowledge, you replace wisdom with knowledge. And the knowledge that is convenient to you. So if you're a dictator, in some countries which shall not be named, but you can imagine, you can create your own narrative, your own knowledge, and you say that's how it is. And then people who follow you and who, and sometimes because they are afraid, and sometimes it's because they are indoctrinated, they will say that's how things are. And that's what creates conflict, because then it creates separation. It creates us versus them, because those who don't agree with what we consider as unassailable knowledge and unassailable facts, unassailable truths, they are the infidels. They are the ones that need to be exterminated or subjugated in some ways. Right? So this is where we find ourselves. Thank you, Socrates. I mean, of course, it's not only Socrates, okay? He blames Plato as well. I don't know how Aristotle escaped his wrath, because I think Aristotle was kind of most kind of specific about these ideas. He doesn't talk much about him, but he talks about Socrates in very derogative terms. Which you can see, but also he says, in a footnote, he says Plato's theory of knowledge, in Plato's theory of knowledge, reality is ideal and can be apprehended only through the intellect. Again, what he means is this discursive intellect, thinking. Of course, intellect is also present when you play music. I mean, we're going to play music on the roof after this talk, right? So, of course, when we play music, and we by the way, we prepared for it. We worked hard, so I hope you appreciate the effort. But when we prepare, we actually look, and when we play as DJs, there are parameters of a song which are important. There is BPM, beats per minute. There is a key. So when you're splicing, when you're mixing two songs or two tracks, of course you pay attention to that. And of course intellect is present. Without intellect, you're going to be cacophony and a dissonance, right? So intellect, when he says intellect, it's a bit loose. What he means here is discursive intellect. It's an intellect which is specifically focused on rational thought, on logical thought, where there is no room, there is no window for the higher wisdom to come in, which is what I prize, by the way, in playing as a DJ. So I started playing as a DJ only recently. And what I love about it is playing without preparation. My natural inclination, if I played alone, would be to just play without any preparation. And how do I select things? I just select them in a moment. That's what I love. And every artist I talk to, every DJ, every musician who is done anything of significance, has, anecdotally, everybody, when I bring this up, everybody agrees with it. They said what we love is being in that flow state, where you are guided by a higher power. And I'm not afraid to say it. By the way, I also believe that when I do mathematics, it's also like that. When we make a discovery, more of that later, when we make a discovery in mathematics, we are also guided by a higher power. The discovery does not come from thinking. In fact, at the moment of discovery, thinking stops to give room for this download, for this insight, which is in some sense perpendicular to the process of thinking. Now, you need to think. And then, the old story goes about Einstein, that he will think, and then he will go on a walk and whistle, and that's when he'll get his ideas. And I think it resonates with me. And again, I spoke to my colleagues. I dug out a lot of citations, quotes from various famous mathematicians and theoretical physicists who are on record saying that. Not to mention, for instance, the great Indian genius mathematician Srinivasa Ramanujan, who actually got his formulas in his dreams. Where is that coming from? He's not thinking in his dream, as far as we know. So in fact, goddess Namagiri, who was a family god, Hindu goddess, would come to him in his dreams and write formulas. And then he would wake up and write them down. And he didn't know how to prove them, right? So I'm just mentioning this story because I think it's kind of an archetypal story of discovery in mathematics, which is, you could say, the most cerebral pursuit. In mathematics, discovery is made when you're not thinking. For sure, in music, this is so. That's kind of intuitively clear. I don't think anybody would argue with that. But even in mathematics, it's clear. So when he says what paramount importance is knowledge, and the true things are, so he came up with this idea of Platonic forms, which is a beautiful idea. But what I have an issue with is that this world of Platonic forms is somehow somewhere out there. So it's not here. So in a sense, it comes to me as a sort of escape from life. So this is life. It's happening right now. And you know how, power of now, or be here and now, the Eastern tradition, Eastern wisdom talks about the power of now, how important it is to be in the now. And so what I would say is that when we are focusing on the knowledge, because knowledge is always from the past. I don't have knowledge right now. I don't have a knowledge of the next word that will come out of my mouth, you see. I have knowledge of what I have already said. So as soon as the ink dries out on the page, it's in the past. But life is evolving, constantly changing. This body is the cells in this body are being rejuvenated at every moment. I can't capture. If I capture, I'm dead. If at any moment, suddenly, things stop, that means death. Life, by very definition, is progress, is movement, you see. So if you focus too much on the knowledge, it immediately, number one, takes you out of now. So you're not focusing anymore. Your attention is not on the now. For instance, right now, if somebody opens their iPhone and starts looking at their Instagram page or something, they're not in the moment anymore because they cannot listen to me. They think they listen, but they're not listening. You see what I mean? So that is a danger. And now imagine how many people today have their life confined to the small screen of a smartphone. You see people on the streets walking and basically hitting various things because they're so focused on those apps or on their iPhone or on their smartphone, you see. So, in other words, to me, there is a direct connection between these ideas, because, these guys, they lived more or less, 2,400 years ago, I suppose, some 2,300, Aristotle, I guess, give or take. So for them, it was kind of theoretical. They were speculating. They didn't know that actually, 2,000 years later, first of all, the world will be built, the Western civilization will be basically built on these ideas. And how we know it? From technology, because our technology is built by people who are indoctrinated by these ideas. Our education system is such that the scientists, people like myself, in our education, we are taught that everything can be understood by discursive intellect alone. Everything is based on knowledge, more knowledge, more knowledge, more knowledge. You're not comfortable not knowing. You run away from the unknown. So naturally, you create technological devices that are enforcing that fallacy. You see, it's natural. So it's not surprising to me. For me, there is a direct connection between the so-called supposedly abstract ideas of these philosophers and what we're experiencing today. The way we are confining ourselves in the narrow rooms and boxes, and trying to see the world also through this very narrow-minded narratives imposed by the governments, imposed by autocrats, but also imposed by multi-billion-dollar corporations, because they want your attention. Attention means money. Attention means profit. So hello, here we are, right? So the reason I'm giving this talk is I'm passionate about this idea of, I call it going back to the roots in the title. But, my dear friend Peter Bauman, I discussed it with him the other day, and he pointed out, he said, Edward, it's better to say not going back to the roots, but how we bring this back with the new understanding. Because Pythagoreans, I would say, it was kind of intuitive. They did not know. They didn't do it kind of like with the idea, gee, we have to keep the balance because otherwise we'll go astray. That was natural for them. But now we know what the consequences are of being too lopsided, too much on the side of Apollo. Now, being too much on the side of Dionysus is not much better either. I'm not arguing for that. I'm really arguing for the balance. I'm not arguing for going to this side or that side. So, in other words, I think Nietzsche is, in a sense, is slightly coming up short, because he's blaming Socrates and Plato. Right? And that's not optimal, in my opinion. Don't blame them, because I think it's a kind of natural what they did. But by taking Pythagorean ideas in the sense of mathematics and logic and reason and running with it. It's like a child who found this toy and wants to play with it. And there's nothing wrong with it. As long as at some point we kind of realize that we were limiting ourselves. And I think the time has come for this, because it's sort of like the world, the conflicts and strife keeps magnifying in the last few years, intensifying, and especially with the advent of artificial intelligence and large language models like ChatGPT, right? So we kind of come to the point of reckoning and the point of realization that we have gone astray, and we have to restore balance. And from my perspective, I try to be kind of more optimistic, and I try to see the beauty also in these ideas. I think it was natural for them to do that, for Socrates, Plato, Aristotle, and those who came after. It was natural to do it, so I don't want to blame them the way Nietzsche approaches it. But I want to say thank you for teaching us the lesson. I wish we kind of got smarter about it before, but the question is, what do we do about it now, you see? So Pythagoreans had this balance. And what I propose in today's talk is the idea of reviving the Pythagorean tradition. Reviving Pythagorean tradition in our age of AI. So how do we do that? Well, first let's talk about what exactly it meant. So first of all, how do we know that they had this balance? So on the one side, Pythagoras had absolutely unassailable credentials on the side of Apollo. First of all, he was predicted by the oracle, who was channeling the prophecy from the Apollo, right? So he was a card-carrying Apollo guy. No one can doubt that the soul of Pythagoras was sent to mankind from the empire of Apollo. Some people actually thought that he was Apollo incarnate. There are all kinds of legends about that. So, okay, so Apollonian side clear. What about Dionysian side? How do we know that Pythagoreans had this balance? Well, we know that they were engaging in rituals, in this Orphic tradition. And Orphic takes its name from Orpheus. And he was a musician. And so, obviously, also Pythagoreans were very much involved in music. Orphic tradition is a direct descendant of Dionysian religion. So that's how we know that they were indeed following Dionysus as well. Rituals. And today we'll have our ritual on the rooftop of Commonwealth Club to bring God Dionysus into our being, okay? So they were able to balance the two sides. And so you say, okay, so what? What are the benefits of it? So they had fun, I guess, right? They had fun, they were highly intellectual, they studied philosophy, they studied mathematics, geometry, and so on. And they were also having fun. So what? Why do we care? So I want to give you a few examples by their achievements that have lived sort of to this day and which set them apart from everybody else, that they were actually ahead of their time. And I would argue that it was exactly because they never forgot the Dionysian side. They never forgot the connection to the divine. Whatever you mean, whatever you understand by that. But you see, when I say divine, what I mean is a kind of a higher intelligence which is beyond the comprehension of a finite mind, of any specific individual at any moment, which is most we can do in this life. But we are connected to it, I believe, innately, whether we realize it or not. We all have intuition, we all have premonitions, we all have dreams, you see. And some of us are capable to translate those dreams into mathematical formulas, like the Indian genius Ramanujan that I mentioned earlier, or like Pythagoras and Pythagoreans. Bernard Russell, for instance, History of Western Civilization, that's early 20th century, he already wrote about the connection of Pythagoras and the Orphic Dionysian religion. Again, religion should be taken with a grain of salt because it's not really a religion, it's more of an idea, or more of a lifestyle, which includes, by the way, drinking wine. And he said a beautiful thing, which I like, that the wine for them was only a symbol, which he connects to Christian sacrament. It's not because you don't drink wine to get drunk, you know? You drink wine to reach this state in which you are more open, in which the thinking mind subsides a little bit. And you become more open to that wisdom of the divine that I'm talking about. And he calls it enthusiasm. Enthusiasm of union with God. And now I want to give you several examples to show how far ahead of their contemporaries Pythagoreans were. And the reason I'm doing that is I want to argue that they were able to surpass their contemporaries, and not only contemporaries, but even philosophers who came after them, was because of that balance, was because they were versed in mathematics, well-versed in mathematics and science of the era. Most kids, if you ask them who's Pythagoras, or even adults, they will say, oh, Pythagoras' theorem, which is a very small part of their contribution, you see. So they were well-versed in mathematics, but they were also open to the divine wisdom and insight. And that's how they came up with ideas which were totally revolutionary. Example one, cosmology. They said they were the first ones as far as we know, in the Western world, to say that the Earth is not the center of the universe. They had a very elaborate model, which was actually written about by one of the most famous Pythagoreans, and is the earliest Pythagorean who left some written documents, Philolaus. Philolaus had a very elaborate cosmology in which actually the Earth was not the center. Sun was not the center either. Sun was also revolving around what they call central fire or hearth. So it was not quite correct from our current understanding. But the crucial element was already there. The Earth is not the center. How many centuries it took for our world, for this to become the kind of common knowledge. And remember Giordano Bruno, not that long ago, being burned on a stake at Campo Fiore, the beautiful square in Rome, for saying otherwise. Even Galileo was on the verge of meeting the same fate. He was smart to postpone the publication of his book until he died. That was clever. Unlike Giordano Bruno, you see. So how did they come up with this? And by the way, Copernicus was the one who actually wrote about this. We call it Copernican system. But in fact, Copernicus gives credit to Philolaus as being his predecessor and precursor. You see. So in fact, what we now know as Copernican system was called Astronomia Pythagorica or Philolaica. So Pythagoras and Philolaus were given credit by Copernicus, who we consider as the originator of the sun-centered cosmological cosmic system or planetary system. He was influenced by this, right? So that's example one. Example two, Earth is not flat. At the time of Pythagoras, that was the prevailing wisdom. Earth is flat. Why? Because this floor is flat, so you come out, it looks pretty much flat, so it must be flat. Even though there were so many ways to discover that it's not flat. For instance, as you can see on this picture, when you have a ship sailing away and it disappears beneath the horizon line, it's not like it becomes smaller and smaller and smaller and disappears, which would happen if the Earth was flat. But first, the hull disappears, and then the mast. If they paid attention, they would say something is wrong with the idea that Earth is flat. But there weren't any people asking the question, apparently, until Pythagoras came. And my argument is that Pythagoreans, so first of all, they had a very good understanding of geometry. They understood that there are two-dimensional shapes, geometric shapes, which are not flat, like a sphere. There is also hyperbolic plane. But once you know that there are different options, there are different possibilities, you see, then you start asking the question, is it flat? Until you realize that there are options, that you have a choice. You are stuck in your dogma and you're stuck in your previous knowledge from the past. So they were able to transcend the prevailing dogma of the era and ask the question. And again, the insight comes from math, by knowing that there is a plurality of geometric shapes. But then, daring to ask the question, I think, also comes from this type of wisdom that transcends the mere knowledge. That's example two. Example three has to do with music, which is appropriate because we are going to play music for you afterwards with DJ Wilder and Anna Fedorova and DJ Cihat Fitzgerald, and myself as DJ Moonstein. My name is Moonstein when I play music. Why is Moonstein? Because I like moonstone. The stones are called moonstones. So I thought of using the name DJ Moonstone, but then I realized it was taken already. So then I realized that stone is Stein, or Stein in German. So Moonstein was not taken. And also kind of rhymes with Einstein, okay? So that's the origin of my name as a DJ. But what I want to say about musical harmony is that in modern terms, you can think in terms of piano. So you have 12 keys in an octave, right? You have seven white keys and 5 black keys. And so the idea is that each note corresponds to a particular frequency. Now, the frequency by itself does not define the note. It also has timbre and other characteristics. But that's the roughest characteristic of a musical note, right? So you have 12 keys, and each of them corresponds to a frequency. And so the idea of Pythagoras and Pythagoreans was that the frequencies, as we go finish the octave and continue to the next one, the frequency should double. Right? So therefore, it's actually convenient to place the notes, and I put here the standard notation that we use, alphanumeric notation that we use today, put them on a clock. So it's like 12 hours, where C starts out at 0, and then as you move along the octave, you come back to 12. So then you get the C of the next octave, and the idea is that the frequency should double. But in the meantime, you have 12 other frequencies, and you want them to be equally distributed so that the frequency of the first note, which is C sharp, I guess, right? It should be some number times the frequency of C, which is F0. F2 should be the same number times the frequency of 1. F3, the same number times the frequency of 2. If you continue this way, you find that when you make a full circle, the frequency of the 12th note, which is again C, but of the next octave, should be A to the 12 times F0. But we want it to double, so A to the 12 should be 2. And therefore, A should be the 12th root of 2. And here we hit a problem, because A to the 12th root of 2 is not a fraction, is not a rational number. And by the way, when people say rational number, it's not because it behaves rationally, it's because it's a ratio. Okay, so irrational means it's not a ratio. And most numbers are not rational. For example, square root of 2 cannot be written as a ratio of two whole numbers, m over n. And that's very easy to prove. I'm not going to do it. By the way, how do we know the square root of 2? We know it from Pythagoras' theorem. 1 squared plus 1 squared should be equal to the square of this side, which is 1 squared plus 1 squared is 2. So that's why the length of this side is a number whose square is 2. That's square root of 2. And likewise, the 12th root of 2 is also an irrational number. And for Pythagoreans, using them in music was kind of a no-go thing. So they did not want it. So there is a quandary. So on the one hand, you have this sort of nice idea of kind of equal distribution of frequencies, and frequency doubling as you go to the next octave, if you make full circle, right? What to do? And then Pythagoras came up with a brilliant idea. He noticed that if you take the 7th note, which is G. Now, this subject is very confusing. For example, it's called perfect fifth. So why is it the 5th when it's actually the 7th? And the reason is you go by the number of white keys and not all keys. So you ignore the 2 black keys that appear. So the 7th note should have the frequency 2 to the power 7 over 12. But if you calculate it, it's very close to 1.5, you see? Or 3 over 2. So Pythagoras said, how about we assign to this 3 over 2, 3/2 of the frequency of C, and use it to generate the frequencies of other notes. And that's called the Pythagorean fifths, or the cycle of Pythagorean fifths. Here's how it works. So you go from frequency of C to frequency of G by multiplying by 3 over 2. Then you do another 7 notes. If you go to if you start something at 7 p.m. and you do it for 7 hours, it will go till 2 a.m. So go 7 steps from 7 is 14, but 14 is 2 on our circle, on our clock. So that's D. So the frequency of D should be what? Should be 3/2 of the frequency of G, but that's 3/2 times 3/2 of the frequency of C. That's 9 over 8. So this way you got now the frequency of D. And then you do it one more time. And you come to A, and that should be 3 cube divided by 2 cube, which is 27 by 8. So this way you generate the frequencies, and they all appear as rational numbers, as fractions. You see? Unfortunately, because it's not exactly 1.5, it's not exactly 3/2. The error accrues, and so at the end of the day, when you generate all of them, there is a gap, which is called Pythagorean comma. If you just do it this way, you hear this dissonance. So you have to do something. You have to make adjustments. And then for many centuries, there were different schools of how to make those adjustments. So there are different temperaments. There is equal temperament, there is just temperament, and so on. But to me, that is a good illustration of the principle that every theory is incomplete. You see, he came up with a beautiful idea of approximating the 7th note with 3 over 2 times the frequency of the zeroth note, which is C. And this way you advance, you find out what the frequencies of other notes are. But it's not quite precise, it's incomplete, so you have to do more. Every pattern we find, there is a finer structure that's not captured by this pattern. That is the message. It's like a fractal. If you know what a fractal is, the more you zoom in, the more subtleties you find that are not clear from sort of bird's eye view. Which, by the way, brings me to a very important point, that for Pythagoreans, numbers were kind of sacred. When I say numbers, I mean natural numbers, like 0, 1, 2, 3, 4, and so on. So Philolaus actually wrote, all things that are known have number. For it is not possible that anything whatsoever be understood or known without this. And this is actually a contentious point, because sometimes this idea is perverted by the saying everything is a number. And people get fooled by this, because it sounds like reducing everything to mathematics and saying everything is mathematics, which, by the way, in my personal interactions, I've had some brilliant musicians telling me, music is really just a collection of notes, so it's just frequencies. What else can it be? It's all mathematical. And that is a mistake. Music has a mathematical component, but music is much more than that. As we see, for instance, in the generating those frequencies, there is a gap. And you could say, kind of metaphorically, that it is this gap through which this divine wisdom comes in, which drives the whole thing. We feel passion, we cry. When we listen to music, we cry sometimes. We get affected by it, not because of collections of numbers. There is something in between, right? So we don't say that very often, but even some of the musicians sometimes get fooled by this, by our Cartesian ideas. Okay? So Pythagorean view was that van der Waerden, who's a great mathematician, German mathematician, he wrote a beautiful book, Science Awakening, in which he gives a brilliant analysis of Pythagoreans, among other things. He said the Pythagorean view is that numbers have both practical and metaphysical roles. And through the latter, human soul communicates with the divine soul, which is what I'm talking about, kind of phrased in a poetic way. By the way, this is a good point to bring Carl Jung, because Carl Jung had this beautiful idea of collective unconscious, which I think is a very nice sort of way to capture what I talk about, which I call the divine. Capture it by kind of neutral terms, which are kind of sound scientific, but it's the same idea. What is collective unconscious? Collective unconscious, according to Jung, is a kind of a common psychic substrate to which all individual minds are connected. You could say that that's the higher intelligence, or universal consciousness of the Eastern tradition, or cosmic consciousness, you see. But now you say it as in terms of analytic psychology, so it becomes more palatable to the Western ear, which I think is a great contribution and kind of very clever approach of Carl Jung to make these ideas acceptable to our somewhat indoctrinated minds. And so Carl Jung talked about collective unconscious and the structural elements of collective unconscious, which he called archetypes. Now, if you read Carl Jung, you learn about the basic archetypes, such as the archetype of a shadow, and the archetype of anima or animus, and the archetype of self. And there's more, like archetype of wise man or wise woman, and so on. But in fact, in his later years, he also speculated that numbers, natural numbers, 1, 2, 3, 4, 5, and so on, come from an archetype. And I think it's a brilliant idea, because it shows you that numbers do not come from physical reality. Now, of course, numbers are manifested in physical reality. I can count you sitting here in the audience. But numbers represent more. In other words, the numbers we encounter in the physical world are manifestations of a much deeper idea of an archetype from collective unconscious. And they're all available to us because we are connected to the collective unconscious. In other words, we are not getting numbers from observing through 5 senses. We are getting numbers through what Charles Darwin called the sixth sense of mathematics. Now, I talk about this, actually. So here, Marie-Louise von Franz, who was Carl Jung's favorite student, she wrote a book, Number and Time, because Jung was already pretty old when he came up with this idea, and he said to Marie-Louise von Franz, who, like I said, was his favorite student, he said, I'm too old now to pursue this, and he basically delegated it to her. And she did a fantastic job writing this book and talking about this in various lectures. So I learned a lot from her about this. And so I'm not going to read, I'm getting a little bit worried about time, so even though time is an illusion, but still. It's an illusion from the, let's say, 5D perspective, but in the 3D world, it's very real, you know, so we have a schedule. But I just want to say that number throws, she wrote this beautiful line in red, number throws a bridge across the gap between physically knowable and the imaginary. And it operates largely unexplored midpoint between myth, the psychic reality, and the physical reality. Quantitative and qualitative, representational and irrepresentational. So I actually did a whole video on this. I have a new YouTube series, which I called Aftermath. So I wrote a book, Love and Math, which came out almost exactly 12 years ago, and it's now been translated into 19 languages. And so a few years ago, I decided to write a sequel, and I thought that Aftermath would be a good title for it. But then I decided to do it not as a book, but as a series of videos. And I've been slowed down, so far there are only 3 episodes, and the latest came out in September. But the previous episode, episode number 2, which you can find at this link, is about this this idea. So I take Jung's idea much further, and I actually propose that all mathematical ideas and all mathematical concepts come from archetypes, not only numbers, but everything else. And I give an argument for that, which actually involves talking about flat Earth and so on. So I argue, for example, that when people were saying the Earth is flat, they were possessed by an archetype of flat space. So for example, the plane, the flat space, like the floor of this room, if you imagine extending it to infinity, which we perfectly are capable of imagining, even though an infinite plane cannot be found in the physical world, because our universe, observable universe, is finite, as far as we know, right? Because we believe today that the universe started with a Big Bang about 13.7 billion years ago, and the speed of light is finite. So therefore, what we can observe in this period of time, 13.7 billion years, is finite. The distance is finite. So how can we possibly imagine infinite plane? So I argue that that's I argue that that's evidence that we connect to the idea of a plane, not through 5 senses, but because we connect to the collective unconscious, where this infinite plane resides as an archetype. Now, you could say that it's very close to Platonic idea, which is that Plato would say the plane is an archetype, is a Platonic idea in a Platonic world. Jung says it's an archetype, and Jung actually gives credit to Plato for Platonic world of ideas. But the idea of archetypes, to me, is much more advanced, because collective unconscious is not somewhere far out. It's not some ideal world to which we connect through our discursive intellect, as we talked about earlier. On the contrary, the world of archetypes, collective unconscious, is what's available to us at all moments. It's inside of us, each of us, you see. So the advantage of Jungian point of view is that you're not searching for some pie in the sky, and you're not escaping from reality. You're just realizing that in addition to the physical world, to which we connect through our senses, through our 5 senses, there is also our mental world, our inner cosmos, if you will, to which we connect from inside. And that's where all mathematical ideas and concepts reside. And if you are interested in this, watch this video. So now I'm going to talk about the revival of a Pythagorean tradition. So I hope I have given you enough reason to see the advantages and benefits of having this balance. So what happened in the last 2,500 years? Has it all been sort of dark ages in the sense of ignoring the Dionysian side? Well, if you look at science, I would argue that there was a brief revival of Pythagorean ideas in the first half of the 20th century, due to a large extent to brilliant physicists and mathematicians such as Niels Bohr. one of the fathers of quantum theory. So Bohr, in fact, acknowledged Pythagoras and Pythagoreans explicitly in one of his books. And the reason why he did that is because, you see, if you look at quantum mechanics was an absolutely revolutionary idea where you say that what happens, the physical systems at the subatomic level are not described by the traditional classical physics, in which you will have some, various physical objects moving at some speed and interacting and so on. But they're described by what's called the wave function, which is a vector in some abstract infinite-dimensional Hilbert space. And what's a Hilbert space? It's a mathematical object. So he said that's a totally Pythagorean idea. So what's a Pythagorean idea? To reiterate, Pythagorean idea was that the world is a sort of symphony of different instruments, of different tones, in which every living being is a particular note in this symphony, if you will, right? Or a particular instrument. And as are the planets and celestial bodies. He talked about music of the spheres, right? And so, what you want to do is to study the patterns and regularities in this symphony, so to speak. And you do that by doing mathematics. So mathematics is a tool to explore. But every time you try to the physical world, so mathematics is, from my perspective, is archetypal. So it comes from the inner world. But you use it to find regularities and patterns in the outer world, in the physical world, physical universe. But the physical universe is far too complex to succumb to any specific theory. So every time you find a pattern in the physical world, it gives you a good understanding of phenomena at in a certain range of energies or distances. For instance, the Earth is flat on a small scale, in a small neighborhood of where you are. But that description breaks down if you want to look at Earth as a whole or a big chunk of the Earth. And likewise with every other physical theory, and we know that to be the case. Newtonian theory of mechanics was extremely powerful, and it described all the phenomena that people were able to reproduce in experiment. But then, when physicists came up with sharper and sharper instruments, and were able to analyze, to look into the subatomic world, that theory broke down, and a new theory had to be created, which subsumed it. We don't discard Newtonian theory, we still use it in a particular range of distances and energies. But beyond that range, it breaks down, and we use a more complicated theory, and so on. So that's the idea. So mathematics, you use it to study physical world, but physical world is more complex. It's like an infinite fractal, you see. And Richard Feynman said that something like, the nature is far smarter than us. It will always keep us surprised. So Werner Heisenberg also was on record. He was another brilliant physicist, but he was also a philosopher who I would argue was a Pythagorean, that he was aware of that mystical side and the creative side, you see. For Pythagoreans, the simple mathematical ratio created the harmony in sound by making but then he is not confined by saying that that's all that there is. Music is just math. It's just numbers. No, he said, they touched an essential point in the development of human thought. Human thought, I take it as something bigger than just thought. Albert Einstein was another wise one, who acknowledged the Dionysian side. He didn't speak in these terms, but he said imagination is more important than knowledge. And he says the reason is that knowledge is always limited. That's what we talked about earlier. Whereas imagination embraces the entire world, stimulating progress, giving birth to evolution. He said imagination is, strictly speaking, a real factor in scientific research, not only in art and music and poetry, which is kind of obvious. I believe in intuitions and inspirations. I'm enough of an artist to draw freely upon my imagination. And then there's another quote, the most beautiful thing we can experience is a mysterious. So again, that's the connection. I would argue that's what he means, is we could say is a connection to the divine that we talked about earlier, which was kind of a cornerstone of Pythagorean's approach to life. And who doesn't know it and no longer wonders, no longer marvels, is as good as dead, for his eyes are dimmed. So here I want to close with this quote from Carl Jung, because Carl Jung spoke about this idea of the divine being, and as an absolutely necessary psychological function of irrational nature, which has nothing to do actually with the question of God's existence or who is God. Is it Jesus? Is it Allah? Is it, No, it's something that is beyond the discursive mind. It's something that's beyond the limitations of any individual mind at any given moment. That's how I would define it. It is human nature to have that, you see. It's human nature. And you can try to run away from it, you see. And it's an archetype. It's a given. It's our nature. We yearn for the connection to the divine. That's what I would argue. Now, by virtue of our education, by virtue of the way we are taught how to speak about things, how to think about things, how to imagine things, a lot of people today run away from it. Right? But then what happens? It has to be parked somewhere. It has to be assigned to something. So what happens, and Carl Jung was very wise to point this out, that it's wiser to acknowledge the idea of God consciously. In other words, you accept the archetype. Because if you don't, it kind of possesses you. And unconsciously, you then project it on something else. He says something quite inappropriate and stupid. Like what? Like worshipping a dictator. Yeah. Like being brainwashed. Yeah. Or worshipping the machines. You have computer scientists today who are completely sold on the idea of artificial general intelligence coming in the next few years and how these machines are going to exterminate us. So I would argue is they take a healthy archetype of the divine, and because they're refusing to accept it consciously, they are projecting it onto something else. So the machines become their gods. But worse yet, they become gods who program the machines. Or they think of themselves, maybe unconsciously, as almighty gods who have the capacity to influence all of us. And that's dangerous. So the danger doesn't come from the machines. It comes from us, from the scientists who program the machines. That's why in the title of this talk, I speak about reviving, the necessity of reviving Pythagorean tradition now, specifically now, when we have this very powerful technology, like large language models, ChatGPT, Gemini, and so on. Because the real danger doesn't come from the computer program. It comes from the programmers and the multi-billion corporations, which for various reasons may actually go in the wrong direction. And the result, and this could affect all of us. So what's important is education, is understanding these ideas, understanding the limitations of the current setup, where we have gone too far on the Apollonian side, you see. There are many other examples I could give you, where unfortunately this revival of Pythagoreans that I talked about was short-lived, because there was this generation of scientists who were wise, not just smart, but wise. Einstein, Bohr, Heisenberg, Wolfgang Pauli, Erwin Schrödinger, and others. But unfortunately, the generations that came later, they took it as a dogma. They took scientific theory as a dogma. And again, there is this idea of theory of everything. Oh God, gosh, we're going to come up with a theory of everything. We'll unify all forces of nature, and we will know everything. So the open-ended nature of scientific project is lost, because you are taking what is available as a knowledge today, and you're claiming that that's all there is. And whatever doesn't fit that narrative is ostracized, is discarded. People are attacked for proposing theories which do not conform to the prevailing dogma of scientific age. String theory is one example. I've been on record criticizing string theory for this, for their refusal to acknowledge that it has failed. It has not lived up to its promise of unifying all forces of nature. And to this day, after 40 years, the captains of string theory, which used to say, this only game in town, And if you want to do high-end theoretical physics, you have to come to us. They have not yet acknowledged the failure. They still pretend that in the next 10 years, it will pan out. We'll find experiment and so on. And is it a surprise that one of the biggest, promoters of string theory, I shall not name the name, but you can easily guess who I'm talking about, is also on record that you and I are bags of particles, which flatly contradicts quantum physics, which he is an expert. So what happened? During the day, he's doing quantum physics, in which it's very clear that there is no such thing as particle. There are quantum fields. And quantum fields cannot be confined. There is a theorem in quantum field theory. You cannot confine a quantum field to a finite region in space or in space-time, for that matter. You see? So, how come he can do physics at this level during the day, but at night he goes and gives an interview to a popular magazine and basically is lying to people that we are bags of particles? Because what is the problem with this idea? The problem is that we're separate. I am this bag and you're that bag, and there we go, bags of particles. Non-existent particles. They are approximations. It's like saying water is a bunch of ice cubes. Yes, it can become a bunch of ice cubes if you freeze it at a certain temperature in a tray, but you take it out of the freezer, it will melt. And where is the separation between the ice cubes? You see, why is that? So, same person is promoting string theory and refusing to acknowledge its failure, is the one who is telling us that we are bags of particles. Now, I used to get very angry about this. But now I am becoming more wise, okay? So the older I get, the more I try to... So what I'm seeing in this is a fear of unknown. There is an irrational fear of, I don't know what reality is. Because you want to control it. And this actually is very clear, very understandable to me, because I was also brought up this way. And I suppose I also had this until recently. And so with that understanding comes compassion. It's not his fault in some sense. So I see my job is not in blaming and ostracizing somebody for this, but to be more understanding and to say, where does it come from and what can we do to our brothers and sisters who are indoctrinated by these ideas? What can we do to alleviate their fear? So say, the unknown is not so bad. Play music. Play music. When you play music, it's the unknown in the next minute. When we play today, that's what I love about it. So embrace the unknown. Don't fight it, which is an inherently Pythagorean idea, you see. In his book, Hero with 1,000 Faces, Joseph Campbell, who was following in the footsteps of Carl Jung, he talks about freedom. So that's what sort of the last thing I want to say is this idea of freedom. So that with compassion, but also with kind of dropping our fears, and also our attachment to the known, comes freedom. You suddenly realize that you're actually free at every moment to be what you want to be, as opposed to follow a certain plan. Whose plan is it? You see, you're no longer captive of any particular narrative. And he talks about the two sort of paradigms, two perspectives, the perspective of apparitions of time, that's Apollo's version, and that of the divine. And freedom means to cut across and connect and balance those perspectives, permitting the mind to know the one by virtue of the other, and that's the talent of the master. Cosmic dancer is a beautiful metaphor. One who is never stuck in any particular narrative. A playful. I like to be in this. I want to do this jig and that jig. But it's not like I'm going to do it for the rest of my life. You see, that's the wisdom. It's so simple. And yet, somehow, is not really the prevailing wisdom of today. But I am hopeful, and I am optimistic. And I want to finish with this quote from the Golden Verses of Pythagoras. And that's a beautiful painting by Russian painter Bortnikov of Pythagoreans seeing the sunrise. The race of humans is divine. Sacred nature reveals to them the most hidden symmetries and mysteries. Thank you very much.